Hey, welcome back. I'm Cody from ATX Hub, and I am absolutely thrilled to have you here for today's explainer. We're going to break down a concept that has completely revolutionized how we handle massive amounts of information, and we're going to do it in a way that just makes perfect logical sense. So, today's focus: PySpark and the Kitchen Brigade. So, here is our foundational question. Why does everyone in data engineering keep talking about PySpark? Seriously, if you look at the tech world right now, it's one of the absolute biggest buzzwords out there. Everyone wants it in their tech stack, everyone uses it, and pretty much every job description demands it. But beyond all the hype, what actually is it?
Okay, let's dive into this. Actually, scratch that. I want you to step away from the computer screens for a second and just picture something with me. Imagine a single chef, just one. And this poor chef is tasked with cooking a massive, complex banquet for exactly 10,000 people. 10,000. That's literally a stadium-sized crowd waiting on one single person to chop, sauté, and plate every single dish.
The sheer scale of the mismatch here is the real problem. You've got this one lone chef working tirelessly on a single stove, yet the expectation is a flawless 10,000-person banquet delivered perfectly on time. And you know what? It fundamentally doesn't matter how unbelievably talented, experienced, or lightning fast that one chef is. The core bottleneck is still there. One person working on a single stove simply cannot finish a job of that magnitude in time. So you just wouldn't run a restaurant like that, right? Instead, you solve this problem by bringing in a kitchen brigade. Imagine hiring 20 highly skilled chefs, placing them at 20 different, fully equipped stations, and having them all cook different parts of the meal simultaneously. Suddenly, you have multiple people working in perfect parallel to get that massive banquet ready, perfectly hot and perfectly on time. And this brilliantly illustrates exactly what Spark is. Let's step out of the kitchen and back into the server room for a second. Spark takes a huge job, just like our massive banquet, and splits it across many different machines working in parallel. Instead of forcing one poor computer to just grind through an entire dataset alone until its fans are screaming and it overheats, it distributes the effort across a whole network of computers, sharing the load effortlessly. So where exactly does PySpark fit into this whole picture? Well, PySpark is simply how you control that massive, busy, distributed kitchen. Think of it as the tool that acts like your ultimate head chef. You don't have to go around and speak to all 20 machines individually in some incredibly complex native language. You just issue your commands using normal-ish Python code, acting kind of like the universal language of the kitchen, and PySpark translates and commands the entire brigade for you. Let's break down the exact flow of this process to see just how incredibly efficient it is. First, you write your Python code. Think of this as writing out your master recipe. Second, PySpark takes that recipe and quietly hands out the work to every single station in the kitchen, delegating exactly who needs to chop, who needs to boil, and who needs to bake. And third, once they're all done crunching the numbers, all those finished data dishes are brought back together into one final perfectly plated result. But why does this matter so much? Look, we aren't talking about a standard spreadsheet with 1,000 rows here. A single everyday laptop can handle that kind of math in its sleep. We're talking about the true intimidating scale of big data. Imagine datasets so incredibly massive, like tracking millions of global credit card transactions in real time to catch fraud, or analyzing decades of global weather patterns to predict storms. Asking one single machine to process that would literally take days, if not weeks. That is exactly where you absolutely need the brigade. Because you have an entire interconnected kitchen working at once, those days of grueling, slow processing, they turn into mere minutes. Spark just chews through those massive datasets incredibly fast. It's no longer one chef sweating over a single stove, hopelessly behind schedule. It's an entire, highly synchronized kitchen working flawlessly at once to deliver your results at lightning speed. It literally takes the impossible and makes it routine. So, to sum it all up, big data, cooked in parallel, that is the true magic of PySpark. But it kind of leaves you wondering, right? If we can now chew through days of complex data processing in mere minutes, what impossible, world-changing problems are we going to be able to solve next? I really hope this kitchen analogy helps you conceptualize exactly what's happening under the hood next time you encounter distributed computing. If you found this explainer helpful and want to keep mastering these complex topics with me, make sure to subscribe to AI Tech Hub. We break down a new concept every single time. Keep learning, and I'll see you in the next explainer.